Hi everyone, so this is going to be part 2 of our logarithms. It's going to talk about some common and natural logarithms and how those are represented, and then some properties of logarithms, specifically how to condense and expand logarithms. So first off, we're going to talk about the common and natural logarithms. These are very easy, they're nothing that you haven't seen before, it's just going to be new notation. So for common logs, log of x, where the base is just completely missing, because remember there is usually a little number down here that says the base. If the base is completely missing, it means it's base 10. For natural logs, it's represented as ln of x, and that means log base e of x. Okay, so if it has no base, then the base is assumed to be 10. If it says ln, that's the same as saying log base e. All right, so we're going to do the same things that we did in part 1 of the video. We're going to be rewriting, we're going to be evaluating, only this time it's going to have log and ln. All right, so for number 18, log of 100 equals 2. Right? And we want to write this in exponential form. So remember, this just means log base 10 of 100 equals 2. So to rewrite it, we do the same thing as normal. The base is 10. The exponent is 2. And 100 is on the other side. For number 19, ln of e equals 1. So ln means log base e, so I'm going to put a little e down there so I remember the base. So the base is e, exponent's going to be 1, equals, e was also inside. That's it rewritten. Going in reverse, we're going to use the same exact idea, just instead of writing log base 10, we're just going to write log. And instead of writing log base e, we're just going to write ln. Right? So to put these as logs, it's going to be base 10, so that's just log of 1/10 equals -1. For e, same idea, just write as ln. So log base e, that's ln of 1 equals 0. All right, so now we are going to go through and evaluate some more. So remember, this is just asking the question. So for the first one, it's really log base 10. So this is asking 10 to what power equals 10? Well, that power would have to be 1 because it didn't change. Same thing, ln of e. That really means log base e. So e to what power equals e? 1. All right, next, log of 0.0001. All right, so to make it look a little more like our other ones, I'm going to go ahead and rewrite this, and hopefully this makes it a little easier. That's 1/10,000th. So we can see that that's a fraction, so it must be a negative. Because again, this is asking 10 to what power equals 1/10,000th. So we know it's a negative. And then to get to 10,000 from 10, well, 10 times 10 is 100. Times 10 again would be 1,000. Times 10 again would be 10,000. So that's 4 times that we had to multiply by itself. So it's -4. right? Next one. This one actually does have a base, but it looks a little weird, so I wanted to make sure to put it because it's going to help us with 26. So this is asking 2 to what power would equal 2 to the 5th? Well, if both of these are 2, and this is a 5, the only way to make that left side match the right side would be if that question mark was also a 5. Then they would be equal. So that's the answer. It's just 5. Putting a 5 where the question mark is would make those sides equal because they'd look exactly the same at that point. So knowing that, let's do 26. So remember, ln is base e. So it's asking e to what power equals e to the negative 5. Again, just like number 25, if we want those sides to match, the question mark would have to be negative 5. Those exponents would have to match. So that's our answer, negative 5. All right, with those out of the way, we are ready to go on to some properties of logarithms. So there's 3 different properties that we need to know to be able to condense and expand logs. So the first one says that if you have 2 things that are multiplied inside of a log, you can split those out into 2 different logs and add the 2 logs. Okay. So for number 1, that's like if we say log of 2x, we can rewrite that as log of 2 plus log of x. All right, so they each get their own log and they're added. Second one. If we have m over n, we can also split those out. So if it's divided, we can still split it out into their own logs, only this time it's going to be subtracted in between. So if we have something like ln of x over 5, we could change that into ln of x minus ln of 5. They each get their own log again, but this time it's subtracted, right? And specifically, the negative goes on the one that was on bottom. The third one says that if inside of a log you have something to a power, that power can actually come out front of the log. So if we have something like log base 3 of x to the 5th, the power can just come out front. So this would end up being 5 log base 3 of x. All right, so those are our 3 rules, and we're going to use those 3 rules to expand and condense logs. Right? And we're going to start with expanding. So for each of these, we are going to have to use multiple of these rules. Not always, but in these examples we are. All right? Easiest way to do it is we are just going to give everything its own log first and deal with the pluses and minuses. So as in, we're going to deal with these 2 first. And then we are going to pull out any exponents second. Okay? So for 27, first thing we're going to do is we're going to give the 3 and the x squared their own log. And since they were multiplied, we are going to add those logs. So we're going to have log of 3 plus log of x squared. Next, we are going to take any exponents and put them out front. In this case, we have that 2 that can go right out front. So we're going to have log of 3 plus, if I can write today, plus 2 log of x. All right, for number 28, same exact idea. Only this time we have some stuff that's multiplied on top and something that's divided on bottom. So we're still going to give a, b, and e their own logarithms. Only in the case of e, since it was on bottom, we're going to make that minus ln of e to the 4th. Okay, so we're going to have ln of a plus ln of b. And then since e was on the bottom, minus ln of e to the 4th. Okay. Now, next step would be to deal with exponents. And then we also are going to be able to simplify this one. If you notice right now that you can simplify something, cool. Do it right now, you'll save yourself a step. If not, it's okay. I'll go back and talk about what we could have done right here. We're going to go ahead and pull that 4 out front, just so we can see it like we did the other one. So that's going to be minus 4 ln of e. And then right here, ln of e. So if I kind of go off to the side real quick and just talk about ln of e, if we ask our question, that's e to what power equals e? Well, that's 1, right? Because it didn't change, so that has to be 1. So this whole thing just goes to 1. So it's going to be ln of a plus ln of b minus 4 times 1, or just 4. And that's our expanded logarithm. Right? Now the thing I said you could have noticed before, we could have done that same exact simplification back up here. Because if we had ln of e to the 4th, we could have still asked our question, e to what power equals e to the 4th? Well, that would have to be 4. So we could have went straight to our 4 and skipped a step in between. But it doesn't matter either way, we still get to the same exact spot. So don't worry if you miss that. You can still simplify it later and it's no big deal. All right, let's try 29. So again, everything's going to get its own logarithm. So 2 is going to get 1. A cubed is going to get 1. B to the 4th is going to get 1. And square root of c is going to get 1. And anything that was on top will be plus. Anything that was on bottom will be negative. So we're going to have log base 5 of 2. And by the way, notice that in each of these, I've just kept using the same base as was in the original problem. So we're not changing bases at all here. We're just using the same base that it gave us. So then plus log base 5 of a cubed minus log base 5 of b to the 4th minus log base 5 of the square root of c. And I'm going to go ahead and move the video over a little bit. That way I don't have to squish it in there. All right, next up is all the exponents. So we have an exponent here, an exponent here, and then I know it doesn't look like it at first glance, but we actually have one more exponent. So remember in the last video, we talked about square roots being the exponent 1/2. So 1/2 can actually come out front. So if you have a square root, you can bring it out front since it is just an exponent. All right, so if we take all of those out, we have log base 5 of 2. And by the way, that one we cannot simplify because there's no nice number that you can raise 5 to get 2. So that one is just going to stay how it is. And then plus 3 log base 5 of A minus 4 log base 5 of B, then minus 1/2 log base 5 of C. And I did forget that 5 there. Okay, so that's expanding. Next up, we're going to talk about condensing. Condensing is going to be the same thing, just going backwards. All right. So since we're going backwards, we're going to do any exponents first, and then we'll put them into one log. All right. So for number 30, no exponents, so we don't have to worry about that. But since these are added, that means they're going to be multiplied. So we're going to have log of 6 times x plus 2. We're just multiplying the insides because it was plus. And then we can actually simplify that a little bit. We can just multiply that out. So that's the same as log of 6x plus 12. That's condensed. All right, and just keep in mind, anytime it says condense, that means you want to end up with one logarithm. All right, for all of these condensed problems, you should never end up with more than one logarithm. It should always get down to 1. All right, 31. So this time we do have some numbers out front. So first thing we're going to do is we're going to put those back inside as exponents. So we're going to have log base 5 of x squared minus log base 5 of y to the 7th. All right, then next up we have a minus. Minus means division. So we're going to have log base 5. Then we're going to have the x squared on top and y to the 7th on bottom. And that's our answer. All right, one more. Again, start off with any exponents. And again, for that last one, since it's 1/2, when we put it in, we can actually write it as square root. All right, so it's going to be log base a of 2 to the 4th plus log base a of y to the 3rd minus log base a of the square root of z. Next, we're going to put it into one log. So I'm going to have log base a. Remember, anything that's positive is going to go on top. Anything that's negative is going to go on bottom. So the 2 to the 4th and the y cubed are both going to go on top. On the bottom is going to go square root of z because that's the only one that had that negative right there. Now there's one more thing we can do to simplify this one. 2 to the 4th, both of those are just numbers. So we can just plug that into our calculator. So we have log base a, 2 to the 4th is 16. It's going to be 16 y cubed over the square root of z. All right, so hopefully that gave a nice overview on, again, common and natural logarithms, and then also how to expand and condense. Again, this was just kind of an introduction. We can definitely go a lot more in depth with expanding and condensing, and there can be a lot harder of ones, but for our purposes, this is more than enough. So if you got these basic rules down, you will be good to go. Right? With that said, I will see you in the next video where we start talking about solving some of these equations. So I will see you in that one.